In this demo, I'll be showcasing the LLM integration layer interacting directly with our autonomous wallet execution kernel on Solana DevNet. The key idea here is simple. The LLM handles decision-making and intent generation. The wallet kernel handles validation, policy enforcement, transaction building, signing, and on-chain execution. This demonstrates a clean separation between intelligence and execution. Let's take a look at the UI. On the left side, we have the Wallets panel. This displays all wallets currently available in our secure store, along with their balances. On the right side, we have the chat interface. This is where a user, a neuris, or an AI system, can provide natural language instructions. The text box below is where prompts are entered. Let's select this wallet since it has a higher SOL balance. Now I'll select the predefined prompt for a transfer. This instruction transfers 0.001 SOL to one of our peer wallets. You can now see the agent processing the request. The LLM generates structured intent. That intent is validated, passed through policy evaluation, and then executed by the wallet kernel. Execution has completed. We can see that the transaction was successful. Let's open it in Solscan. Now we can verify directly on-chain that the transaction did indeed go through. Returning to our interface, we can also inspect the AI's reasoning. It clearly states, transferring 0.001 SOL, which equals 1 million Lamports to the first known peer wallet as requested. Below that, we can expand the generated intent. Here you can see the structured transfer intent produced by the LLM. It includes the intent type, the source wallet, the destination wallet, the transfer amount. This shows that natural language has been converted into a strictly validated execution intent. Now let's intentionally violate a policy to demonstrate enforcement. I'll enter. Transfer 12 SOL to a peer wallet. The agent begins processing the request. Now we see that execution failed during policy evaluation. The error clearly states that 12 SOL exceeds the configured spending limit of 10 SOL. Interestingly, the AI even warns that the balance may be insufficient, yet it still produces a structured intent. This is important. The LLM is not trusted. It only generates intent. The wallet kernel enforces security. Because the spending limit policy was violated, the transaction was aborted before any signing or network submission occurred. This confirms that policies act as a hard governance boundary. Now let's try a swap. I'll enter. Swap 0.0001 SOL for USDC. The agent generates the structured swap intent. The wallet kernel evaluates policies, builds the transaction using the Orca Whirlpool protocol, signs it securely, and submits it to Solana DevNet. Execution is complete. Let's open the transaction in Solscan. We can verify that this was indeed a swap transaction, and we can inspect all on-chain details. This confirms real DeFi protocol interaction through an AI-generated intent. Now let's look at how this works under the hood. Starting from the browser, the user provides a natural language prompt. This prompt is sent to our API server. The API server forwards it to the LLM agent layer. The LLM generates a structured intent in strict JSON format. That intent is then passed into the execution pipeline. Inside the pipeline, the intent is validated. All active policies are evaluated. If approved, the transaction is built. The signer retrieves keys from the secure key store boundary. The transaction is signed, the adapter submits it to the network. The transaction is confirmed on-chain. Finally, the execution result, including the transaction hash, is returned back through the API and displayed in the browser. This ensures a clean separation between decision logic, security enforcement, and transaction execution.